Welcome. We're just going to give it another minute as I see participants number is climbing right now, so we'll just let everyone join. Thank you. All right, I guess we'll get started. Welcome and thank you for joining the Boston University Institute for Sustainable Energy for today's Energy of the Future webinar on the decarbonization of existing commercial buildings as we focus on policy and financial issues following last month's webinar on the technical side. I'm Liz Beardsley, Senior Policy Counsel at the U.S. Green Building Council, and I'm pleased to be moderating today, representing the U.S. GBC as the ISE's series sponsor this fall in support of the Institute's work on decarbonizing our built environment. All of the ISE's research on sustainable cities, energy and water systems, and sustainable finance can be found at bu.edu/ISE, so check it out. In addition to the USGBC, today's discussion is also sponsored by the student-run BU Energy and Sustainability Club. We're delighted to welcome the members of the Council, the Club, and all of you who have joined us today. Before we get started, please note the webinar is being recorded. It will be available on the ISE's website and YouTube channel. Please feel free to add questions for today's speakers at any point using the Q&A button, which we'll get to live after the presentations. So appreciate that. Today we're focused on existing buildings, and there's good reason to do so. In 2019, the Intergovernmental Panel on Climate Change, IPCC, issued its 1.5 degree report as a target maximum warming level to avoid the worst impacts. This report identified that for buildings representing nearly 40% of end-use energy-based greenhouse gas emissions globally, new buildings need to be net zero, like essentially now, and the pace of deep retrofits of existing buildings needs to double to around 5 or 6% per year. That's a lot of buildings. Along with that, we're now recognizing the growing significance of embodied carbon. At COP26 last month, we saw official adoption of the 1.5 degree target, along with some increased commitments from nations and a focus on actions over the next decade, now to 2030, as critical to keeping that target in reach. Here in the US, the building stock that will be adding greenhouse gas emissions in 2030 is largely already built. We have much technology, knowledge, and examples of successful retrofits of all kinds of buildings, getting to very low energy use, net zero energy, and even net zero carbon. Yet deploying these advances and getting existing buildings on a track to decarbonize at scale and at the pace needed is a challenge. Our panel today will explore key drivers to make this shift with the focus on policy and financial frameworks to help decarbonize the sector. Our lineup today is great, representing technology, research, practice, finance, and policy. So really looking forward to the presentations and our discussion. We're going to start with Jacob Knowles, Associate Principal and Director of Sustainable Design at BR+A. In this role, Jacob leads the BR+A Sustainability Consulting Team. He's a zero net energy guru, spearheading millions of square feet of carbon neutral and carbon positive projects. Jacob's also a board member of the Boston Society for Architecture. Brenda Pike is the climate advisor at the American Cities Climate Challenge, working with the City of Boston. In her current role, Brenda focuses on buildings and energy projects such as performance standards, financing mechanisms, and workforce development. Previously, she was at National Grid designing residential energy efficiency programs for Mass Save and at the MAPC, Regional Planning Agency, assisting cities and towns with clean energy projects. Brenda will talk about Boston's new Building Energy Reporting and Disclosure Ordinance, birdo 2, requiring large buildings to achieve carbon neutrality by 2050. Michael Javelber ISE affiliated faculty, Associate Professor of Mechanical Engineering at Boston University, will be talking about his research on developing enhanced materials processing capabilities through modeling, sensor development, experimentation, and integrated systems and control design. This research includes developing a new system identification approach to optimize airflow in existing commercial buildings and conducting energy assessments for urban housing and universities. Michael will be talking about the cost of alternative reduction strategies and trade-offs. And Peter Flynn is co-founder and managing partner of Bostonia. Peter has experience in the financing of energy efficiency, distributed generation, and renewable energy projects, as well as project finance, real estate finance, securitization, and public-private partnership. At Bostonia, he's structured and placed over $2 billion in federal, municipal, and commercial energy projects. Peter's also a graduate of BU School of Law. He'll discuss opportunities to attracting capital to deliver decarbonization of commercial buildings at scale. And I want to acknowledge you, our audience, our partners today in this session. So with that, let's turn it over to Jacob.
Great, thank you so much. Just get my slide going here. Oh, it looks like actually I don't, oh, there we go, share screen. All right, how's that look? So electrification of existing buildings. Let's just start by talking about electrification of buildings in general, and net zero buildings is growing exponentially in the market across the entire United States. And in Massachusetts, Built Environment Plus recently came out with a report showing that there is 5.5 million square feet of net zero buildings in construction or operation in Massachusetts, and 7.2 million that are net zero ready, as in they are entirely, or if not almost entirely, fully electric buildings that are ultra efficient and ready to run on clean renewable energy. And part of what that study looked at is what is the cost of net zero. And of the respondents, 85% showed that the construction cost premium was less than 1% compared to conventional design. So that's probably the biggest driver of all that's made this possible, this rapid growth of net zero buildings. And so we've been working on many of those types of buildings and actually finding similar results in terms of the construction cost premium, typically being able to keep it below that 1% mark. Now that's for new construction, right? That's a lot easier because you have a big budget to work with. But the approach to net zero between new buildings and existing buildings is pretty consistent. So starting with load reduction first, you have to have a good envelope or make envelope improvements. You have to have efficient mechanical systems with high performance heat recovery. That then brings the loads down low enough that electrification, using heat pumps as your source of heating the building rather than burning fossil fuels, becomes not only viable, but makes it more cost effective. So let's look at some existing buildings. We're going to talk a little bit about a few different building types, including higher ed, historic buildings, healthcare, and even labs and pharma manufacturing. So kind of going from easy to more and more difficult. So for higher ed, we've been working on some projects for UMass Lowell, UMass Boston, and others, URI Narragansett Bay Campus, for example, also. Looking at how do we achieve carbon neutral for their entire campus. And there's obviously on a higher ed campus, there's a wide range of different building types, different conditions of the different buildings. Some are new, some are old, some are failing, some are in great shape. And so they have a wide range of energy performance. And some of the key considerations that you have to take into account is how does it interact with the future growth of the campus? If you're going to be looking at district energy systems that are going to provide heat pump based heating and cooling, you want to plan for that future expansion, the transformation of the campus over time. Another big factor is what level of retrofit is viable for the existing buildings to bring that load down first before you start to invest in electrification. And another big variable is, do you go with standalone electrification, or do you do precinct plants, or do you do a big central plant? And different campuses really lend to different solutions. So again, one of the key steps is bringing those loads down. So we typically start by looking at the existing facilities, the existing buildings, identifying energy conservation measures, and particularly thermal heating load reduction strategies. So it's not just about energy reduction, but it's also about reducing that peak load, you're going to use that peak load to size your heat pump plant. So the more you can bring that peak down, the better. And then based on looking at good, better, best, essentially levels of enhancements to the existing buildings. You can see on the left here, kind of business as usual, good or best level of retrofit options. And then you compare those with different types of heat pump strategies. You could do ground source. That's kind of the old school go-to, is to go to ground source, because air source is a relatively newer technology. But now the air source technology has been accelerating, and market adoption has made it really a viable option. So we often want to look at a hybrid where we're looking at some ground source and air source combined. And then the third option is to say, well, do you need to be 100% electric, or can you be 95 or 99% electric? Because those last few percents at a district scale often are the biggest drivers of that peak system capacity. And so as you start to look at what your scenarios would be, interpolating between those levels of retrofit and the different heat pump strategies, you can see there's a wide range of different outcomes in terms of how much infrastructure that you have to put into the plant itself. So comparing a couple of options, you can see as soon as my computer stops bogging down on me here. Come on. There we go. You can see that, for example, the number of boreholes in a good level of retrofit with a fully geo system on the left is 2,000 boreholes for the geothermal system. Whereas on the right, it's only 450, because number one, we've reduced the load. And number two, we're not trying to hit the absolute peak, and we're using air source heat pumps as part of a hybrid ground source air source system. And that can be not just a budget driver, but it can actually be the deciding factor of whether you can even fit the number of boreholes you need onto your campus at all. So once you've looked through all of that set of options and picked your optimal outcome for that campus, then you start to look at, well, what is your investment plan over time? Because you can't just snap your fingers and spend $200 million and retrofit everything at the same time. So you want to be strategic in your sequencing of those retrofits, both of the buildings and of the infrastructure, and look at that in time increments that are logical for the planning of the campus. Ultimately, having a real roadmap for your operations to understand what are you going to spend when, and what does it cost you to then operate that system from that time forward. Ultimately, working your way towards a fully carbon neutral operation. So that's some higher ed examples. Historic buildings are a particularly unique challenge. We're working with the city of Somerville right now on all of their major city buildings, not including the schools. And some of these buildings are historic. And so you can't just rip out the windows and put in a modern triple glazed window with fatter frames that have the fully insulated system. So in some cases, maybe the best you can do is the sash replacement and weather stripping. Not ideal, but a lot of these buildings have relatively low window wall ratios. So if you can't go all the way in with super high performance windows, and you're really just trying to focus on air sealing and avoiding those leaks, that's a good option. Strategies like smart vapor barriers and proper insulation techniques on the inside of existing masonry load-bearing structures is an important thing to evaluate. And then retrofitting the mechanical makes a lot of sense, looking at ultra high performance heat recovery on your ventilation air. And ground source versus air source again comes up here, where maybe in a historic structure, you don't want a bunch of air source units on the outside of the building, and you want to look at a geothermal system. Healthcare, even bigger challenge, not only because it has higher loads and all these critical systems, but also in a lot of cases, you have third-party central utility plants that are providing heating, cooling, electricity in long-term contracts. So It's a challenge to figure out how to navigate the transition either away from those plants or collaborate with the utility providers to achieve a common goal of moving towards either electric or other hydrogen, for example, fuel sources. And finally, labs and pharma have even higher loads, particularly pharma manufacturing. Some pretty amazing technology is coming available now from the industrial world, where there are even heat pumps that can make steam. Sounds impossible, right? But if you have enough compression of the refrigerants, you can get it hot enough that you can boil water. So that's something that we're looking into. Also, all that exhaust air leaving your labs, huge energy resource that we're just not taking full advantage of with a conventional heat recovery system. So we're tagging heat pumps onto those heat recovery systems to basically supercharge them and create an exhaust source heat pump, a whole new world of heat pump systems by pulling heat out of the exhaust air. So this the really exciting things happening right now. And just to kind of bring it back to the beginning, you show that exponential growth of net zero and all electric new buildings. It was really unlocked by that moment where it became cost effective, and it became, all these precedents started to build and show that it was possible. Well, same thing here with existing infrastructure on these big campuses and high energy buildings. We're starting to prove this out. We're starting to unlock it, and then there's going to be these precedents, and everybody's going to realize it's achievable, and there's going to be a sea change of transformation that's going to happen. So we might need a little more financial leverage. For example, like birdo carbon emissions fines is going to be a lever on existing buildings that will start to tip the cost scales. But it's very exciting times.
Thanks, Jacob. I can see there's a lot of heat pumps in some of the solutions, and that's really a big change that's occurred. And we're seeing a lot of electrification policies as well, including some potential federal incentives in the Build Back Better or reconciliation bill that's under consideration now. So a lot of people are asking us, like, when and where will electric heating and cooling reliably lower carbon emissions compared to the fossil systems they're replacing? Are we already at that point? Like, what's your perspective?
Yeah, so that's another really cool thing is if you try to run an electric resistance like a toaster oven to heat a building compared to burning fossil fuels, there's a lot of places in the country where you're going to actually increase your carbon emissions. But that's what's so cool about heat pumps is they're not a 1 unit of electric in equals 1 unit of heat out. They're a 1 unit of electric in equals 2 or 3 or 4 units of heat out. And so, for example, in ISO New England, like here in Boston, if you put in a heat pump versus a gas boiler, day one, you're 50% lower emissions because the grid is clean enough and the heat pump is efficient enough that you cut your emissions in half. And then you can ride the grid down as it gets cleaner and cleaner over time, as it's regulated to do by law, to get closer to zero. Or you buy renewables today and you're carbon neutral on day one, such as what Boston University has done. So yeah, using heat pumps is really unlocking our carbon neutral future right now.
That's great. All right, well, thanks. Well, we'll get into that some more later, I'm sure. Next, we're going to go over to Brenda Pike.
Great, let me just share my screen. There we go, can you see that?
Yes.
Perfect. Okay, so I am I'm a climate advisor working with Boston's Environment Department through the American Cities Climate Challenge. And I've been very involved with the development of Boston's Building Emissions Performance Standard, better known as BIRDO. So I'll be mostly talking about that, although I'll touch on how other performance standards across the country compare. So I don't need to talk to this group about the importance of climate action, but why focus on buildings and why large buildings? So in Boston, large buildings account for 70% of our greenhouse gas emissions, and just 4% of those buildings account for the majority of those emissions. So that means that focusing on large buildings is the most impactful thing that we can do right now. And so that was recognized in 2013 when the first version of birdo was created, which covered buildings 35,000 square feet and up. And it required annual reporting, but also an energy action every 5 years. And that action could be reducing your energy use by 15% or doing an ASHRAE level 2 audit to identify how to reduce energy use for the next cycle. So it wasn't really a performance standard as we think about them now. And it wouldn't get us to the city's goal of carbon neutrality by 2050. So we decided to revise birdo, setting out targets to 2050 and giving buildings the flexibility to choose how they fit those targets into their capital improvement cycle. So we expanded the buildings that needed to comply to anything 20,000 square feet and up to align with small project review for new construction. And recognizing that every building is different, it leaves paths for owners to comply by combining their buildings together into a portfolio, by applying for an individual compliance schedule, or applying for a hardship compliance plan. And decisions about these will be made by a new review board, 2/3 of which will be people nominated by community organizations. And that review board will also be making decisions about how to spend a fund that the alternative compliance payments will populate. And I'll talk about those in a little bit. But more information about all of this is available at boston.gov/birdo if you want to dig in some more. And the targets are set by building type, and whether you look at it by floor area or emissions, the 4 largest building types in Boston are office, multifamily, healthcare, and education. So we'll just zoom into the standards for those. So these standards were developed with our technical advisory group, which was managed by Synapse Energy Economics and included building owners, engineers, architects, etc. Probably some of whom I think are here today. And they looked at our benchmarking data for the last 5 years to set standards that were reasonable for each building type, but still met the city's 2030 and 2050 goals. And these are set in kilograms of CO2 equivalent per square foot per year. And here you can see the different options that a building has to comply. And this flexibility is important, not just to the building owner, but to the city too, because Boston doesn't control its own building code. That's handled at the state level. So we have to make sure that we aren't requiring particular equipment. So you can see here we're factoring in the greening of the grid according to Massachusetts plan. And then to meet any given target, a building owner can choose to do energy efficiency upgrades, which will generally be the most cost-efficient option right now. They can do fuel switching to some sort of renewable heating and cooling, likely electrification right now. And they can purchase either on-site or off-site renewable electricity, or they can pay an alternative compliance payment. And the alternative compliance payment is not a fine. There are fines, and those are set out in the ordinance. That's a standard amount per day, regardless of how close to compliance you are. But the alternative compliance payments are really intended for building owners who, for whatever reason, miss their target in a given year. And so for that incremental amount that they can pay into a fund to help decarbonize other buildings. In order not to disincentivize building owners from using other methods to comply, we set the alternative compliance payments to the average amount to decarbonize a building in Boston, which Synapse and the technical advisory group estimated to be $234 per ton. And actually, let me go back here. If you want to dive into how that the alternative compliance payments were calculated, Synapse's technical methods overview is available on boston.gov/birdo. They estimated emissions and uses and costs by building type using not just birdo data and the ASHRAE 2 energy audits that we received through birdo, but also tax assessment data, market characterization studies done for the Mass Save programs, EIA data, and the Carbon Free Boston Buildings Technical Report. And to see how all of this might apply to a building, Synapse developed some case studies for different building types. So for instance, Here they looked at an audit for a multifamily building with high emissions. And I know this is a lot more information that we can get into here, but you can take a closer look at the slides when they're sent out after this. But for this particular building, it makes the most sense to choose an individual compliance schedule. And then the major improvements that would get the building to those targets would be insulation at the end of the roof life in 2025, a VRF system by 2035, and heat pump water heaters by 2040. And you can see the incremental abatement cost above which they would normally spend on their capital improvement plans is $89 per ton, $22 per ton once you factor in those energy savings, which is significantly less than the alternative compliance payment. So we're hoping that being able to do that comparison will really help building owners to make decisions about this. And this gets into a little more detail about how they might choose to comply with each target. So in 2030, they don't have any retrofit plans. That doesn't fit into their capital improvement cycle. So they might just choose to purchase RECs for the amount that they're over the target. And then after 2040, they can just ride the grid to net zero. And this gets into a lot more detail about the costs and savings for different measures. Again, you can take a closer look at this and the two other case studies that are in the appendix when the slides are sent out. But pulling back a little bit, performance standards are being used across the country, with 7 jurisdictions right now having adopted them. There's a lot of information sharing going on between cities about this right now. I mentioned I'm working with Boston through the American Cities Climate Challenge. So 25 cities were chosen for that. And then also a group of cities have worked with the Institute for Market Transformation to learn about these policies together. And there are some key differences between them. So for instance, Boston and New York have focused on emissions intensity for their metrics. But Denver, St. Louis, Washington State, and Washington, D.C. have all focused on energy use intensity. Different cities have different exemptions. For instance, New York exempts affordable housing because it would bump up against their rent control laws. Some of them, for instance, Denver, require each building to be on an individual pathway to net zero with a set baseline for each building and an individual trajectory for each building. DC requires all buildings meet the median Energy Star score or energy use intensity, which is reassessed every 5 years. So there are benefits and drawbacks to all of these options, which are explored during the stakeholder engagement process. And all of these cities are different. So it makes sense that these laws are all slightly different, even if we're trying to get to similar goals. So I think I've talked long enough here, but if you have more questions and you can't find what you're looking for on boston.gov/birdo, you're welcome to reach out to me. And here's my contact info.
Thanks so much, Brenda. It's just really impressive that Boston has taken on this approach to the challenge of existing building retrofits and really put all the effort into with the modeling, financial impact, and kind of trying to think about not just adding the regulatory standard, but like how buildings would actually cope with that and implement projects to get there. One question you touched on, sort of like the proliferation of building performance standards in cities across the US. I'm just wondering how, like in general, what trends are there as far as, are those generally trying to align with the 1.5 degree target or with carbon neutrality by a certain date? Like how do you kind of see the cities getting, you know, what's their ultimate target, and are the birdos like aligned to meet those, at least for that sector?
Yeah, most cities that are doing this have similar net zero by 2050 goals, and 50% reduction by 2030, which is also what Boston has. Mm-hmm. Although there is some variability in how they are applying that to large buildings in particular.
Okay, well, it'll be good to see. I know we're hopeful that as these projects start to take shape, that'll just start to get momentum and really create a new sort of market and demand for these kind of projects and retrofits. So we'll get into that more in the Q&A, but we're going to now go over to Michael.
Thanks very much. Let me get my setup going. Great. Well, thank you very much, Liz, and really enjoyed hearing from the other speakers. This is really important and exciting work. So I'm going to be reporting today on a study we've been working on for the last year or so. It's funded by the BU Campus Climate Labs. We appreciate their funding of this. And I have to put my disclaimer in this. We're looking at how do we decarbonize BU's major buildings, but this is our own work. This is not, we're going to be pitching this to university management, but this is not a done deal. This is just our preliminary thoughts on this. So I'm going to start off by giving you a framework of what does it take to decarbonize BU. Just mention some of the technical issues. That presentation was done a month ago, so I'll refer you back to that. And our focus is on our financial analysis and some policy questions. And I want to appreciate the students working with me on this. 3 excellent mechanical engineering students, Gayatri, Sabrina, and Kathy. So what's BU's requirements? It turns out 40% of our greenhouse gas emission comes from heating loads, and that spans 274 buildings and about 12 million square feet. So this is a huge area to really figure out how do we achieve this. Our focus that we're presenting here is on the 14 largest buildings. Why? Because if we address those 14 largest buildings, similar to what Brenda was saying, we're going to reduce 46% of the heating greenhouse gas emissions. So we want to attack that first. It allows us to focus and achieve a lot with a very focused effort. And our driving question is, how do we electrify and achieve the greatest percentage of reduction for these heating systems in the shortest time, meeting the thermal requirements we have, as well as the capital and operating budget constraints. But we think a lot of the work we're doing here is going to be applicable to a number of other existing building sort of studies. And on the right-hand side, I'm outlining what our major issues are. What's the cost per metric ton of CO2 emissions to do this decarbonization? And what's an equivalent carbon tax? How do we figure out how much we actually have to pay, how much our operating costs are going to go up? And then what are some of these trade-offs in terms of capital cost, operating cost, and thinking about this from a net present value? Oops. Cool. So just to give you a sense of what we've been considering, as other speakers have talking about, you've got to do that energy efficiency first, but ultimately you're going to come to replacing the natural gas boilers that are being used, and either boilers in buildings, or we also have 2 steam loops. And what are the technologies that really are at play here? There are going to be these heat pumps, lower temperature heat pumps, higher temperature heat pumps. And I'm not going to go through the details of the cost, but these systems cost significantly more than the conventional boilers. So already we sort of see there's a significant capital cost to doing this conversion. And another consideration, as I mentioned, is high temperature, low temperature. Why is that important? Because you're doing this for an existing building. All the heat exchangers in the buildings are set. If you can avoid ripping those out and replacing that, it is a much more economical solution. So what were some of the key takeaways from the technical requirements studies? there's a bunch of key considerations that we've looked at. How large a heat pump or heating system do you need to replace what you already got? And again, if since it's typically going to be heat pumps, this is going to be much more expensive than the natural gas boiler. So you want to try to minimize the size of the heating system, but yet meet the heating load. And that leads into the capacity factor. I'll say a little bit more on the next slide, but that's the percentage of time that you use this very expensive piece of capital equipment. And then most importantly is, what temperature does this alternative heating system need to supply to the building? Because you're working in an existing building. Many of them were designed with 180 to 190 Fahrenheit operating temperatures, and heat pumps, it gets much more expensive to supply that high temperature heat than the sort of the current default value of 130. And then most importantly, when you add these electric heat pumps, are you going to fry out the electrical system within the building? And we also have to consider the supply from the grid to the building. So these were issues we talked about in the previous talk. So let's focus in terms of this heating capacity. And so in this plot, what I'm showing here on the bottom axis is the outside air temperature for, we're just beginning this heating season in Boston. So my comments today are focused on, Boston heating requirements, but this really reflects what's going to be done for all the northern part of the country. And if you look on the right-hand side, I'm showing the number of hours for each of these temperature degree bends, and that corresponds to this data shown here in these blue dots. That's the number of hours at each of these temperatures through the heating season. And on the left side, what I'm plotting here is the percentage of maximum heating capacity you need to meet that particular load. So the highest load is at this -5 degrees Fahrenheit, and that's where you would need 100% of that heating capacity. But if you look at these blue dots here, you see right around 30 degrees, the number of hours for 30 degrees, when you go lower, takes a nosedive. And the question will be, if I try to meet all these coldest degree days, I'll use a lot of capacity. And the idea we came up by looking at this is, if I size the heat pumps for this 30 degree bend so that I can meet that 30 degree heating load, but then use our conventional boilers already installed in the building, I can significantly reduce the capital costs because I don't need that many tons of heating capacity of very expensive heat pumps, and I can rely on what's already established. And that's what we're calling here the hybrid solution. We're proposing that you size the heat pumps for 40% of the peak load. That's going to significantly reduce the capital cost. We're going to use that conventional boiler that's already there for the coldest days. And there's two benefits that you can achieve by that. One, besides saving capital costs, I can increase the capacity factor, what percentage of the time throughout the heating season I'm using these heat pumps, to 64%. And so it's a much more economical solution. So the downside of this is I'm using those conventional boilers. I'm still emitting the greenhouse gas emissions, but our analysis shows you can achieve a 92% reduction in greenhouse gas emissions. And then really what's going to go on is, okay, we're going to do this for 10 years, 15 years, and then we'll look at the state of the art of heat pumps and other options. You could use actually an electric boiler, which is another low cost, low capex sort of option, but it significantly increases your electrical demand, but we'll reevaluate in 10 years. Okay, so how did all this financial analysis shake out? So what I'm plotting here is the different options I've been talking about. The two on the left are the sort of the business as usual, the natural gas boiler. The second column assumes that we're going to pay that alternative compliance fee called ACP that comes in at about $234 per metric ton of CO2 that you emit. And then the middle two options are these hybrid solutions. The third column is focused on air source heat pumps, low temperature, and then comes the ground source heat pumps, where you do have to drill those deep holes to operate those ground source heat pumps. And then the last two options are full air source heat pump, but high temperature because we got to meet that load on the coldest day of the year, as well as ground source. So if you look at this, what I'm indicating here is in terms of costs. Oh, so one last thing. The orange column represents the capital cost. The green column represents the net present value. We're evaluating that at over 20 years at 4.5% interest. And the red dots represent the annual operating expense. So either the natural gas and or the electricity and or the ACP payment. So let's drill down and see what we can get out of this analysis. This lower dashed line, that represents the annual or the net present value of the conventional solution, but not paying that ACP. This is just what we're paying in a net present value over the next 20 years. And so this is a lower bound. This is our, I call this the business as usual cost. If you then take a look at the second column, what you would pay if you kept running that natural gas boiler and you were paying that $234 per ton of CO2 emissions, this is what I call the birdo cost line. So if you're operating somewhere between BAU and birdo cost, you're saving money. You're going to be spending more money than by continuing just your natural gas boiler operation, but you'll be less than what you'll be having to pay under birdo. So it looks like our two solutions of the hybrid solutions, both in terms of the air source heat pump and ground source, are have a comparable net present value, and you're also operating less than the birdo cost line. The important difference we see is the ground source heat pump has a 60% premium in CapEx cost. So the question that raises is, are we going to be limited because of a limited access to capital? Are we going to be limited in how quickly we can roll out that program? So, because we're trying to do this decarbonization over the entire physical plant. And both air source and ground source high temperature options are significantly more than that birdo cost limit. So questionable, if you have enough capital, maybe you want to go there, but from an engineering perspective, you have to raise that question. The advantage, though, of those high temperature systems is you get 100% decarbonization. So the options, the hybrid options are limited. They'll still have like 10% carbon emissions. So that's going to be the question. How does this look if we roll this out for those 14 key buildings? Here I'm showing for the first a 12-year plan, you would start with the pilot buildings. You've got to develop some experience, both for how do you construct these things, how do you operate them successfully, what brands are good to run with. And then we propose for a 4-year period, 1 building a year of these very large buildings. And then once you've got that experience, you can be implementing on the order of 2 buildings a year without overwhelming the facility staff. This plan would, for these 14 buildings, would account for about $30 million capital investments. Our operating costs are going to be increasing, but relative to that birdo cost, we're saving money. So I wanted to take in this last eye chart slide, I wanted to take a look at what does the whole university's emissions look like relative to the birdo requirements. So here I'm plotting as a function of year, from 2025 when birdo starts up to 2050, and I'm plotting the carbon emissions per square foot per year, which is the metric that birdo is using. Oops. And here in blue, this is the birdo 2.0 requirement for the whole university. And so this is how currently, as Brenda said, they're going to be ratcheting it down. In red here, I'm showing what are the current BU for the whole campus emissions. So we're well under the university requirements up to about 2030, and we don't bump into the birdo requirements until about 2030. Well, what's the cheapest way we can meet those requirements? Cheapest way is to just buy green electrons, to even buy more green electrons than the grid is being required to achieve in Massachusetts. My estimate is that's going to come in around $50 a metric ton of CO2. So you can immediately, drop our emissions down to here, which puts us under safe headway until about 2040, okay? And that's when you're going to have to really implement these solutions of changing over the heating plant. But that's a much more expensive operation. I sort of see that as something like an incremental heating decarbonization cost of about $100 per metric ton. So I think the question, that Boston needs to think about is they set this $234 ACP payment. Is that going to be enough to drive large existing buildings to change their heating systems? Because this is really complicated, really involved. So I can understand why they set 234, but if you're just sort of at parity with 234, what's going to be that real driver to do that? And if you look at the impact of electrical and suspending the need to change fossil until 2040, well, what you'd like to do, or what I'd like to see us do, is can we figure out some incentives to drive people to start changing over these fossil plants significantly earlier? Now, anybody who really develops a plan to implement changes, I rolled out a 12-year plan. That's what you would need to be doing over this period of time. So you wouldn't wait. Yep.
Yeah, we're just at maybe one more minute or 30 seconds to wrap up. Okay, thanks.
So what you would like to do is, can you develop an incentive plan to get people to start taking action early? Any serious player knows they need to do it for the time of planning, the experience. But just like my students, myself, we always wait to the day before an assignment is due, and that just really won't fly. So the question is, what incentives can be created for those early movers? So in summary, what I'm proposing here is a hybrid strategy. It achieves a 90% carbon reduction, significantly lower cost than other options I see on the margin. And then after running for 10, 15 years, you could switch over to get even further carbon reduction. I've just gone through what the estimated impact is for birdo for the whole BU campus. But the climate needs, as I think we know from COP26 and over the last couple of decades, we need quick action. So how do we drive that? Can we create some incentives for early movers? So with that, I will stop sharing.
Thanks, Michael. Yeah, that was great and really cool to see all the analysis that was done and sort of how that plays out in terms of, cost versus your sort of mission and cultural values and how that plays out. I think given time, we're going to go right over to Peter, and then we'll start with you in the Q&A. If that's all right, just staying agile here. So over to Peter. Thank you. Peter, we see your slide, but I don't hear you, so just check your mute.
Sorry about that. You knew
There we
someone
go.
would have their mute on. I volunteered to be that person. I was just saying, I just wanted to thank real quickly the Institute for Sustainable Energy, the U.S. Green Building Council, Liz and her team, and the Energy and Sustainability Club. This has been a really great, I've enjoyed the presentations thus far, and hopefully I can add to it. I think Michael, created a nice transition to talk a little bit about financing. So we can go to the next slide. And that's just a little bit about the firm. And the next slide after that, we can jump in because I know we're a little time constrained. So I think both Jacob and Michael made the point about, accelerating development of projects and delivering on these ambitious carbon reduction goals, whether it's Boston or Denver or Ithaca, New York. There are a bunch of cities following suit here. We're going to need to, I think they've made the point sort of indirectly that we're going to need to leverage private capital. In Jacob's example, he mentioned a university that doesn't have $200 million available to undertake sort of a campus-wide project to deliver on their goals. And Michael was addressing sort of the BU's capital commitments that it would require. And one way to do that is through financing and introducing and leveraging private capital to these types of projects. So I wanted to start, and I have a couple of slides, and I'll talk first at a high level about the sort of basics of energy finance. What does it look like? And then I want to just talk a little bit about sort of the building blocks of a program like Birdo that would attract capital investment, and we can of private capital investment. We can maybe dig a little deeper in the Q&A, but I'll just sort of touch on that at a high level based on our experience. What are the building blocks for a successful program? So the basics of energy finance. Energy finance is project finance. It's cash flow driven. It's revenue driven, value stream driven, and all of that is delivered through a contract, whether that's an energy services agreement, a energy savings performance contract, a PPA, et cetera. There are a variety of contract vehicles out there, but they're all about driving cash flow through revenue, et cetera, to deliver a financing. These financings are typically structured as non-recourse financings, and that just simply means that there's no ultimate obligor out there that's going to write a check if things go sideways in terms of the four corners of the contract and the four corners of the project. So these projects really have to rely on the revenue streams that they generate. The third piece is that these types of projects, as we've seen through the presentations, are capital intensive. They have high upfront costs, and that typically means that they're going to require long-term contracts to amortize those projects and those upfront costs over time. So that's a little bit about the basics of energy financing. What does the capital stack look like for these types of projects? The most important piece, and these go from least expensive to most expensive, debt is critical. Leverage is critical in these transactions to make them work, to deliver these projects, and to deliver low-cost financing. And that's typically supported by contracted for revenues. Again, there are a variety of contract mechanisms out there, but we're looking for contracted for revenues to deliver the least cost financing. The next in the level is tax equity. If you're delivering a renewable energy project, solar, wind, et cetera, ITC, the investment tax credit, production tax credit, depreciation benefits, those all fit into that sort of tax equity bucket. And then finally, there's sponsor equity or project equity, which is the most expensive. To deliver on a program or a project, really you want to maximize your debt. So that means focusing on developing those value streams that can be contracted for and monetized. to deliver that low cost of capital to deliver these projects at scale in order to meet really ambitious and important goals that we have. And we can go to the next slide. So that's a little bit about financing. Wanted to talk a little bit about what a successful program looks like from an investor's perspective. And these are very high level, but we sort of have three building blocks of a program that's going to attract investors and keep investors engaged and active. First is, and I've mentioned this already, but standardized contracts. Standardized contracts create the important features of repeatability and efficiency in these types of programs. And obviously longer contract terms allow for the delivery of whether it's deep retrofits or campus-wide projects, citywide projects, et cetera. And that is matching often with those longer tenors. You can match shorter payback measures that may pay back and allow for a 5-year contract with longer payback measures that might require a 20-year contract or 25-year contract or longer. But if we're trying to reach these goals, we want to take advantage and deliver as much project as we can, deliver deep retrofits, deliver full building, full campus electrification, et cetera, will require those longer contract terms. Another thing that investors seek in programs that are set up for financing are transparency in the procurement process, transparency in how these contracts and programs are administered, the regulatory structure. Clarity is critical, whether it's around the requirements of the program, the enforcement of the program, meeting the timing of the program in terms of rolling out projects and rolling out meeting a variety of goals under those particular projects. And also they look for continuous improvement because obviously when you're starting a new program, there are going to be tweaks along the way. And it's important that there's a process for that continuous improvement and stakeholder feedback along the way. And then finally, scale. Investors are looking for a robust pipeline of quality projects because in order to become involved in a new program or a new undertaking, it's a commitment of resources, both human and capital resources to ramp up a program, understand the program, and make a commitment to that particular market. So investors want to see if they're going to commit those resources and support a program, they want to see that there's a pipeline of projects that are coming to justify that commitment of resources. So that's an important piece. And some thoughts around, how to reach scale, incentives to participate. Michael just talked about that. How do we give building owners and other potential participants incentives to participate in these programs and incentives to move quickly in undertaking these types of projects and delivering carbon reductions and GHG reductions? Can we leverage public investment through backing credit enhancement or otherwise backing lenders in case of default in certain instances? And we can talk a little bit more about that. And obviously aggregation is key. Building scale, getting to scale in these programs quickly, allowing investors to put capital to work and support these programs. But we also have to keep in mind that it's often not one size fits all. A residential program is going to look a little different than a program at Boston University versus a program for large office buildings. So we have to keep that in mind as we're designing these types of programs as well. I think one of the keys is we've got to move past the pilot project to a programmatic approach. The first project in a program is always the most difficult. You learn a lot of lessons, but if that leads you to developing a program and executing projects and reaching scale and velocity, that's critical. But if every deal that you do or every contract is a first, that becomes a real drag on attracting capital and getting to the results that we need. And I'll stop there.
That's great. Thanks, Peter. And could you share any examples of successful deployment of capital for deep retrofits, like some of the programs you've been involved in?
Sure. There are a couple I think that are good examples, and there certainly are more than these, but these are ones that programs that we have participated in and have a history with. The first is, and it's obviously not a one size fits all, but the federal energy efficiency, water efficiency programs, the energy savings performance contracts, and utility energy services contracts. And those are performance contracts where it's a federal program authorized by Congress, where private sector energy services companies enter into standardized contractual agreements with federal agencies to design and install energy and water conservation measures at government facilities. So it's got the standardized contracts. Agencies are mandated to participate. They have goals they need to meet in terms of energy savings and water savings. So that's a real driver for these programs. And in fact, in the Obama administration, they specifically targeted these programs, and under they called it a performance contract challenge, they were able to push forward about $4 billion of these projects over 4 years. So having incentives, having a real focus on pushing out the projects is critical. I think the other critical piece of these is, this requires knowing why it's supported really across the aisle. It's a bipartisan support of these programs across presidencies, across Congresses, because there's no upfront costs to the federal agencies other than procurement costs. No special appropriations from Congress. The legislation requires that the projects are paid for out of the savings that they produce. They have long-term contracting authority, 25 years, which allows for really deep retrofits, and the federal government really pushes, and the agencies push for these deep retrofits. So we often see contracts that are 25, go up to 25 years, large projects. I think the largest one we participated in was $260 million at an Air Force base to essentially retrofit the entire campus or installation. They also have, the government vets the ESCOs that participate. So we know, as a capital provider, we know we've got partners that have been vetted by the government, and we have an alignment of interest there. So to date, there's been about $9 billion of private capital invested in this program, in these programs. Really efficient capital, strong investor appetite, and I think in a lot of ways, and a strong pipeline coming. I think estimates are $10 to $15 billion worth of these projects to reach the current goals, and it really checks the boxes, right? It's got standardized contracts, transparency, and a history around the procurement process and contract administration, and they've reached scale. So it's a good example. And do you want me to stop there, or?
Yeah, and I was just going to jump
Okay.
in that, I think as you mentioned, the Obama administration executive order, and there were requirements that agencies meet certain goals, and those agency mandates have kind of waxed and waned at times, and we've
Yes.
actually been working with Senator Cardin and Congressman Sarbanes on a federal buildings act that would help put some of these, into codify some specific targets for decarbonization and use of performance contracting to try to make sure that those are more consistent, established goals over time, even if administrations change. So,
Yeah.
anyways,
that's an important factor. Yeah, absolutely.
Yeah. I want to invite all the panelists to come back as we dive into some of the Q&A here, and thank you to all the participants and our audience for being engaged. I'm going to group them because there's some similar patterns, but we will try to get to as many as we can. So there's a few related to cost, and as we are looking to scale building retrofits, it has to be attractive and achievable for businesses. So I guess just big picture, do deep and net zero retrofits pencil out? Jacob, you want to start us off there?
Yeah, sure. I think, what we've seen is you have to be really strategic to make this stuff pencil out. And Michael did a great job of explaining, if you try to go all in on full, heat pump retrofit, you're gonna break the bank, and you're spending twice as much. Let's say you're going to do 40% heat pumps or 100% heat pumps. You're spending more than twice as much to input the infrastructure, plus all the electrical increased infrastructure, and then you're only shaving off the last few percent of fossil fuel annually, because it's rarely at that peak that needs all that capacity. So that's key strategy number one. The other is, you got to have a really comprehensive plan in place from day one. And you have to have a system by which you evaluate and prioritize those decisions so that you're working holistically. Because number one, if you put in a new fossil fuel piece of equipment or a new high temperature system that can't be retrofit with heat pumps, tomorrow, boy, you're going to be kicking yourself down the road. So you got to at least be making sure you're all marching in the right direction on all your projects. And you got to take advantage of those big end of life opportunities, right? When, oh, this whole system needs a major overhaul, or, oh, we're going to renovate this whole building. That's the aha moment to say, like, well, let's do this different. If you go to a building that's 10 years old or a system you just replaced recently, that's a giant waste of money and embodied carbon to rip that out prematurely. So it's a long-term process. You got to have a plan in place to be successful.
Thanks. And one of the questions on this topic was whether we're able to account for kind of some of the costs in the future, as well as some of the maybe reductions in costs. So for example, how energy costs are going to change over time, avoiding peak load charges that might be in the future, what increased efficiency and lower cost technology, as I know Department of Energy is investing tons of money in trying to get the cost of heat pumps down. So are you able to account for some of those trends, at least in some of the analyses now, to make that long-term plan? Are we still sort of basing it on data that's as of today and then like tweaking it going forward? Because that could be a big shift. Anyone? Michael, do you want to take it? Or go ahead, Peter. Yeah.
No, I think that's where I think, to Michael's point, that's where mandates and requirements and a regulatory regime would help push that, right, and accelerate that and really drive participation. And Liz, to your point, I mean, we see all the time in a variety of financings we've been involved with where within the contract, whether it's a performance contract or energy as a service, et cetera, you can build in those sort of value streams, if you will, avoided costs, O&M costs, if you're going to transfer those to a private partner, or manage those differently or reduce those. If you're going to avoid a capital cost in year 5, a boiler replacement or roof replacement, what have you, you can build that into your cash flow and monetize that and contractualize that. And I think the other piece of it is, from our perspective, when folks are looking to do, as much project as they can, a deep retrofit, campus-wide or building-wide or what have you, the longer the tenor of that contract, right, and the longer the tenor of the financing is going to drive, more of that project. You're going to have more cash flow available, and obviously that's a decision that a university or a building owner needs to, take on their side as well. But if it's contractualized, it can be monetized and it can be financed.
I would just add, I'm not a politician running for office, so a politician can't say we're going to do it. We're going to count on the reduction of price. I just don't see that. Saving the world is going to cost some money, and we're going to have to make some economic choices here. And that's why it's brilliant, that Boston has been a leader in putting out these regulations, because you have to meet regulations, and it doesn't force you, if you go to the board and say, well, instead of betting, moving up the university rankings, we're going to divert money to be more sustainable. No, the board is always going to push you to be the best you can in your area. So these regulations are really, really important, whether they come from birdo or carbon tax. We've just got to do it. On the other hand, energy has been a commodity. If you look at your budgets for most organizations, it's something like 2%. So time to step up to the plate and do this. But it's going to be a real challenge to get everybody moving as fast as we need to.
Brenda, curious on that, what you're hearing from the market. I know, like I said, you did a lot of work to try to analyze costs and different alternatives that would be available for compliance. What's the response been? Are you going to continue doing modeling as things change and maybe add in more incentives or as federal things become available?
So as part of the ordinance, the city has committed to reassessing that sort of modeling every, I don't think there's a particular time frame in there, but on a regular basis. We have heard from building owners who have reached out to us in these early days since this has been passed, that they, like BU is, that they are taking this into account when they're making decisions about their capital improvement plans. That's great to see. And we're sort of thinking of this as a building owners need zero overtime plans, right? Like they need to be factoring this in, and not trying to make these changes all at once necessarily, but if they are trying to sort of make go net zero in a really cost efficient way, to be factoring in, end of roof life, factoring that in there, or, if you're projecting that, for instance, one of the questions I saw was electrifying thermal loads, is it not economical until 2035? Well, if that's, what your projections are seeing with your fuel type, with your current fuel type, then, that might be the point when you decide to make that change. So that zero overtime plan is really important.
Thanks, Brenda. All right, so let's see here. Here was a technical question for Jacob. In comparing state-of-the-art heat pump efficiency with conventional gas boilers, is it appropriate to consider thermodynamic efficiency of the power plant? So I think this is, site versus source, essentially.
Yeah, absolutely. So when we talk about comparing burning gas on site with a boiler versus making heating with a heat pump, in terms of that comparison, we typically look at it in terms of emissions. So that's accounting for, on the boiler, what is the total emissions on site, as well as some of the upstream, prior to the delivery. There's a bit of a, emissions factor there. And then there is the heat pump. And when you're talking about emissions from the heat pump, you're looking all the way back upstream at the grid and all of the generation sources, that whole mix, to say how much emissions is happening to make that heating happen at my building.
And Jacob, how are you, when you're looking at that, are you looking at time of use as well? That's, really important with more renewables coming on board, but where fossil is still used for peak demand. So if a campus or a building can shift demand and keep their peak down or use off-peak times, often aligning better. Yeah.
Absolutely. That's really the future. We need to be thinking more in terms of actual impact, not just kind of a mathematical impact, but like, are you actually emitting more at any point in time? So smarter, grid integration, where we're getting that feedback real time, or at least in the analysis process of deciding how to set up your control logic, recognize that, running it at a high peak can have higher emissions. So that's an important thing to consider.
A couple of questions for Michael. One is whether, first of all, whether 2050 should be the goal versus 2040, and whether that was discussed. And then did you consider the cost of replacing the existing central AC in the business as usual case? Is that right?
I didn't quite catch that last question.
Did you consider including the cost of replacing the existing central AC for the business as usual? Since heat pump can also provide space cooling, it could be included as part of the comparison.
Right. So we're doing essentially a feasibility study, and we want to give the university a sense of what's the budget requirements, when do they need to start doing it, and then they're going to hire the pros who are the real MEP companies to really, because they've designed and built stuff, so they know what really works. So I'll defer that last question over to BR+A. We did look at that issue of, we've looked at the current interval, 15-minute intervals of how much electricity we use and how much additional electricity we're going to use because of these heat pump systems. And there's got to be a big reckoning between the grid supplier and and everybody on the grid. So I think another expense nobody's factoring in yet is how much more robust or larger electrical grid we're going to have, because when it's minus 10 degrees outside, all the buildings are going to face that load. So it's really hard. You can shift it a little bit, but there's going to be some very interesting grid dynamics. And the first question was what?
I think there are a few comments about whether BU should try to hit carbon neutrality earlier.
Well, I think,
2040
when you look at climate science, we've got to reduce, the faster we can reduce CO2 emissions, the better the world's going to be. So 2050 is, from climate models, but man, if we can drive as quickly down, that's a net plus. But then you get into the whole regulatory thing. What's going to drive owners of buildings to do that as fast as possible? And we're just looking at this, and can we add these air source heat pumps to the roofs of building? Will they fit there, as we've discussed before? But we should do that as soon as possible. And if you can afford it, don't wait. We rebuild boilers. You don't just replace the whole thing. Year after year, you're going to be rebuilding it. So can we make these investments as soon as we can? And what's going to convince, the president and the president of the university and the board of trustees to do some sort of deal with Peter or do it self-financing, but to begin this now, because it takes a long time to do this whole thing. We've got 12 million square feet that we've eventually got a plan for. So I want to get going as fast as we can on that 14, but we need some sort of a push to motivate people to go there.
And Michael, you have a few suggestions in the Q&A for either tapping philanthropy or even like using the building naming method of fundraising to put people's names on decarbonization activities.
Your name will go on the heat the top of the building. The president knows how to do that extremely well, but and we started these discussions. What's our capital budget? And if we're spending it on this, we're not spending it on that. These are really tough questions that each organization needs to confront.
So I want to turn to the sort of the supply chain of how building retrofits happen from the owner, the engineers and architects, through the finance, and sort of each of these touch points. There's a lot that's owner driven, or regulatory, but how do we, as in the design finance communities, sort of make the most of our roles? We don't necessarily make the final decision, but we can influence and show options. So for example, I know couple architecture firms that are going to be doing on every project, offer a net zero energy option. So that's at least something that's before the owner when they're making their decisions. Another firm is committing to do embodied carbon whole building analysis on all their projects. So getting the information to owners is part of it. The more we can, optimize incentives and show financial value, I think that would also be great. But I'd love to hear the group's thoughts on that.
Yeah, just from a firm's perspective, I can say that we aim to provide a carbon neutral option for every major project we work on. And some of our services are that's the whole scope of the work, is providing carbon neutral solutions. But I mean, thousands of projects a year, there's always going to be something that just kind of does the status quo. You can't be perfect everywhere, but I think everybody's recognizing that not only is it the right thing to do and something that we care about, but if at this point, if you don't offer your client a carbon neutral solution, you're probably failing them as a service provider, because at some point in the future, they're going to ask you, why didn't you give us an option? Because it's going to be something that their constituents and funders and other people are going to be asking them.
I would just say from a financing perspective is a lot of times it's a bit of an afterthought. But I think, it's helpful to bring your financing partner or a financing partner in early to these projects and do an analysis, understand, excuse me, the type of contract mechanism you'd like to undertake to deliver these projects, whether it's a performance contract, whether it's energy as a service. Some of that's driven by who owns the assets. No upfront. Do you want to deliver a project with no upfront cost, no use of capital, the university or other capital, and treat it as an operating expense? There are a variety of approaches to deliver these solutions from a financing perspective. So, in part, understanding the ultimate customer, and I'll use what BU's goals are. I mean, do they want to use their own capital, or would they rather shift some of that risk to private partners and bring an energy services company or otherwise in to undertake a program, take on some of the risk for performance, and deliver capital to undertake that project? So, paid for out of the savings it produced or other value stream that's developed. So I think it's important to sort of bring the financing in early so you develop a solution that works for you.
Thanks, Peter. Couple of questions with some technology questions. One is, we've talked a lot about Boston and sort of the cold climates, but what about really humid climates? Are these kind of technologies available? And Jacob, you talked about, which I thought was great, less than 1% added first cost to get to net zero in a lot of your projects. Can that be done in a place like Miami? Are we there yet?
It's funny. We have two Florida offices actually, and one's in Miami. So there's a long history of doing all electric buildings in Florida because it's cheap. There's not a lot of peak heating load, and it's cheap to run electric wires around the building to reheats and whatever else you might need. So shockingly, a place that maybe isn't as climate focused, although now they are with the sea level rise, maybe hasn't historically been as climate focused as Boston or Massachusetts or New York, is actually in good shape to buy renewable energy and just work on efficiency because they don't have a lot of fossil fuel consumption in some buildings. But it's actually, and also if you have an existing building that is using gas, it's a lot easier to transition to heat pumps where you're using a mild ambient temperature as your source. Very efficient. They can put out more heat at warmer ambient conditions. So there's actually higher capacity for each heat pump module at those warmer air temperatures. So we're kind of under trial by fire here up in the Northeast, working on probably the most challenging climates to solve this problem. And it really, if we can do it here, you can do it anywhere.
That's great. Just to follow up there, Peter, what are you seeing for sort of demand and market activity in kind of the southeast part of the U.S.? I think we have, generally across those states, less of a building code and regulatory push. So we're going to need a lot more market demand and perhaps federal incentives to make that.
I think so. I think if we look at our portfolio of projects, that's probably one of the lower region. I think, again, that's driven more by technology solutions than financial solutions. So I think, delivering those types of projects up in the Northeast and colder climates makes a lot more sense. But that's not to say we haven't done projects in the Southeast, I think. But if you sort of aggregate them, there's probably lower velocity there.
Right. Well, that's something we'll have to work on. Another technology that I find really interesting, and one of the commenters asked about, is thermal storage in buildings. And this is, things like chiller beams and other things that, are different ways to store energy or thermal demand. How are you all seeing that? Like, Brenda, is that something that's come up in the birdo context? To the extent you're looking at specific technologies, is that something that can help at scale?
So, birdo is very much technology agnostic. I don't know that I've seen that necessarily in buildings that are currently doing retrofits right now. So I would love to hear from from Jacob, especially if you've seen things for other buildings that are in plans right now that would be using something like that.
Yeah, absolutely. So as we transition more towards air source and to using less ground source, thermal storage becomes more and more important. And so because the ground, in a sense, is your thermal storage system if you use ground source. So as you move towards air source, the other thing that's a big variable too is how much of fluctuation do you have in your load? So for example, if you have a morning warm up in the building, or if you have a residential building with domestic hot water, and then everybody takes a shower in the morning or they all cook dinner in the evening, those peaks really drive you to be more cost effective if you can use thermal storage than if you try to size your whole system for handling that peak. So there's a great technology out there, both a small scale for like your house, as well as the big scale for huge commercial buildings for domestic hot water to use thermal storage. We were looking at a 1 million square foot hospital project recently where we were going to put in 25 air to water heat pumps on the roof and 6,000 gallons of thermal domestic hot water storage as a pairing to avoid the need to put in, say, 4 or 5 times as much heat pumps. So the thermal storage is a huge player in that case to reduce the construction cost. The same thing with central plants, like for UMass Boston, we're planning to incorporate thermal storage into the design because we're looking at a hybrid ground source, air source system, so that thermal storage will play a role at the central plant to fully take advantage of those air source heat pumps so they can run more continuously. You need fewer modules, and you can also load shave.
That's great.
There are some interesting demonstration project proposals from Eversource and National Grid to do district geothermal systems. And I think that's something that we'd love to see more of in the future.
Well, at USGBC, for over a decade, we've been encouraging and rewarding LEED projects that reduce embodied carbon. And one significant way to do that is through the reuse and rehab of buildings instead of tearing down in new construction. So to today's topic of existing buildings, we've talked a lot about the cost of that rehab, but kind of what are you seeing as far as like awareness, policy, and drivers for reuse as a strategy in and of itself versus new construction?
This is definitely something that's being discussed in Boston, but there are no current plans right now to incorporate that into birdo, although it's definitely, embodied carbon is definitely something that will need to be assessed in the future.
Michael, has that come into play at all in terms of, thinking about campus needs and, I think universities are always changing to meet current research requirements and sort of putting a heavy, a thumb on the scale towards retaining buildings and reusing them versus new construction. Is that a factor in your carbon planning?
Oh yeah, when you talk to the facilities, the planning managers, they understand that issue, and to a T. We have a certain amount of funds each year we use to rehab buildings in a major way, but BR+A is the MEP for our new data sciences building. And we had data science people spread out over the whole university, and they decided to just build a new building to bring them all together. It wasn't possible to find all that space together. But this is, the university made it a commitment. This should be correct me if I'm wrong, but it's a net zero building, or it's no carbon emissions, and it's totally with ground source heat pumps. And it's really, you've got to develop experience. So that's the job of the president talking with the planners, and they do that. When we brought, for example, the theater department on campus, and there's a new building there. Do I wish that we had less glass exposure? Sure, but when you build these new buildings, you can also make them, if they're achieving your your operational goals, you can also do a great job of building them much more sustainable.
It's definitely a lot of trade-offs. Well, we're at time, so I want to thank everyone again for joining us and our excellent panelists. This was a great conversation. I think we could go for another while if we had time. And I want to thank the BU Energy and Sustainability Club and the Institute for Sustainable Energy that joined with USGBC on this webinar. And the ISE has some additional webinars this spring with the Energy of the Future series, shifting to AI and sustainable energy. So again, thank you for joining us, and let's thank the panelists. And this recording for the fall series will be available at bu.edu/ISE/fall21. So thanks again and enjoy your weekends.
Thanks, Liz.
Thank you.
Good to see everybody. Thank you.
Thank you.
Thanks very much. Enjoyed it.